Ko, Siri Hendrica Bickerton, toko ingoa, no tamaki makoto, aho. Hi, my name's Siri Hendrica Bickerton. I'm a lecturer in public policy, in case anyone doesn't know me. I also want to acknowledge my colleague, Bianca Depati, who's been a part of the research team. Just a little bit of background before I get into the material. We started this in 2021. Yeah, in 2021, I got invited in to be part of a transdisciplinary research team. I'll get into who these people are later on, and working towards this. It got funded by the University of Auckland's Transdisciplinary Ideation Fund, because we had people from public policy, engineering, physics, environment, etc., across the university. And we were really interested in looking at net zero carbon and sustainable futures, particularly with in the context of looking at what the space sector in New Zealand thought what counted as sustainable practices. It was like where they were at in terms of their development. We ended up using, well, we are using currently some what's known as the 3 Horizons model to develop current state, future state, and transitional state. A paper based upon that model for where we might want to be at for this, where we currently are. But part of that was getting a sense of where the industry saw itself and what could be going on. So that was the research we did. I'll get into the methodology for this in a little bit, but I thought we'd start off and go through a few things around. I'm going to give some background on what we consider now new space, then specifically new space in Aotearoa New Zealand, what the sector looks like, a bit of stuff around the space agency policies context in New Zealand, and then getting into sustainability, our approach and our result, and our results and findings. Okay, so new space. It's a colloquial term that's been coming to represent the shift that's occurred since the end of the 20th century across the world, in that there's been a shift for space activity funding, because it's reduced since the end of the 20th century by quite a bit. And part of that has been a notable shift to what we can colloquially or largely call public-private collaborations. In other words, effectively, state operators contracting out provision of services to private sector providers. Okay? This was the emergence of the new space economy. America had a longer history of this, but they still did a lot of their space activities through NASA. What has happened with new space is that further contracting out of a lot of provision of services, particularly around launch technologies and space vehicles, has now been moved out of NASA and given to private entities, which has been one of the big shifts. It's characterized by increasingly cost-effective, democratized, I'll put that in quote marks, access to space via commercial launch providers, SpaceX, Rocket Lab USA, technically Blue Origin, but yeah. We've got revenue is expected to be around US $1.8 trillion by 2035. Currently, it's driven primarily by satellite-based broadband, low-gravity manufacturing, and, surprising nobody, defense. Many countries are prioritizing development of national space ecosystems, which includes access to venture capital, developing a workforce around this, a nice regulatory system that is flexible, and actually having a presence in the space economy and in space itself. Okay, so this has been the big shift. it's effectively a decentralization. I hesitate to use the word democratized. I would probably consider it a bit more decentralized than democratized. So keep that in mind. But it's allowing far more players, for better or worse, to be involved with space. Specifically for New Zealand, it was catalyzed by Rocket Lab USA in 2016. And almost immediately afterwards, the formation of the New Zealand Space Agency, which is a unit within MB. And they were effectively, Rocket Lab caused the New Zealand Space Agency effectively, because we suddenly found ourselves as a space launching nation, which we hadn't had before. I often describe New Zealand as the accidental space nation, because we suddenly found ourselves with the space industry. We never had one. Now, the interesting thing about the New Zealand Space Agency, NZSA, the unit within MB, has two primary roles. Okay, one is that it works as a regulator. Two is that it operates as a business development unit. Okay? Now, anybody that might pay attention to politics and public policy might notice that's a little bit on the contradictory goals level, a conflict of interest that has never really been properly addressed. It's never really been addressed. Okay, they've never really come out a statement about them. They do refer to themselves. We were at one of the national aerospace conferences just recently, and they came out on stage and described themselves as New Zealand Space Regulator. Although their major efforts are in this area. But what's happened in New Zealand is actually resulted in a growing national aerospace ecosystem. We've got startups, established companies, educational research institutions, special interest groups are involved. As of 2022, approximately, there were approximately 230 distinct entities in the sector. It's surprisingly large. In 2019, they contributed New Zealand like almost $2 billion. Admittedly, that's 0.5% of New Zealand's GDP, so it's not huge, but it is, $2 billion here and $2 billion there, and then eventually you're talking about real money. We're only like 0.25% of a global space economy. But Rocket Lab USA actually plays about 1.5% of the New Zealand amount, by the way. Okay, so they're probably the single biggest, but we've got a lot of other things going on in New Zealand. MB is aiming for annual revenue of 10 billion by 2030. By the way, you'll see the 2030 figure pop up in a lot of situations here. It seems to be the planning goal for a lot of strategy documents in New Zealand and overseas, that everybody talks about 2030. So that's a date that'll pop up quite frequently. Now, the major unique nature of New Zealand's space industry is that we're one of the very first nations to be a wholly private sector space industry nation. Previously, most nations, all nations that had space launch facilities were either had their own publicly funded space launch facilities, or had built them in other countries so that they could launch in more advantageous locations around the world. So it was all public sector initiatives. What's happened then is that most of these places have then developed private sector on top of the public sector. It's like this democratized, decentralized approach to so the space industry has started to occur. We never had a publicly funded space launch provision in New Zealand. Our first launch, as I said, was in 2016 from Rocket Lab. So we've been right from the get-go a private sector located space industry. And that makes us pretty unique in the world. Most other countries, as I said, it came out of public sector before it went into the private sector. Okay, so what does the sector actually look like in the context of New Zealand? And this is fairly common to what's across most nations as well, is a good typology to begin with is to break things out by Earth activities and outer space activities, sourcing raw materials, design activities, manufacturing assembly, blah, 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 the use phase of things, and end of life. Terrestrial activities, space activities, we're actually growing at quite a large amount off planet. It's one of the busiest times in human history for getting things into orbit. And there's been a lot of concern about the sustainability activities. Space debris is of a major interest. This little image here actually shows what's happening with a lot of telescopes. A lot of the stuff we've got, particularly in low Earth orbit, but most orbits are causing problems with ground-based observations. I've got another photo that I'll show in a little bit. We also have an important bit to remember. You've got the impact from terrestrial activities, you've got the impact from space activities, but then we've also got another part of the sustainability frame of these space activities, which is space collected information. Often known as Earth observation data, as a critical provider of data to help understand and respond to sustainability issues, Earth observation and monitoring of significant interest. So if you think about this as impacts to sustainability, but contributions to dealing with sustainability, this is part of the way in which the kind of activities that are occurring at the moment. And New Zealand has pretty much does most of these things. If you're interested, the two major launch facilities we have in the country are Mahia Peninsula, and that's up on just on the east coast of the North Island. This is Rocket Lab's launch facility, funded entirely by Rocket Lab, and contributions from the New Zealand government. This is Tawhaki on Te Tiriti Spit, just southeast of Christchurch. This is unique in the world in that it is a partnership between Crown and local hapu to develop a launch facility together. At the moment, they're doing what's known as horizontal launch, and with the eye to eventually making it up to vertical launch. I've been out there. It's incredible. The amazing thing about what a lot of people don't realize about New Zealand is that it's actually a really great place to launch space vehicles from, because most launches go from west to east. It's because of the rotation of the Earth. Okay. And you generally want to launch over a space where nobody lives, okay, for safety reasons. And I don't know if you guys noticed, but there's a great big whopping great ocean out there that we can just launch over, okay? One of the interesting things I often think about is Vanderbilt Air Force Base, where SpaceX often launches out of on the west coast of the United States. It has to launch over the empty portions in the plain states, but they're not really that empty anymore. And so it's actually that's actually a really dangerous place to launch from. But that's the space where you get those amazing nighttime launch shots of, if you've ever seen the pictures of SpaceX rockets, that's where it tends to go through. But most of the time you launch out over water. Okay. So that's what it looks like. Now, just a little bit of a hint. Again, looking at New Zealand's history, in September 2022, two documents were released, which was developing the Aotearoa New Zealand aerospace strategy and the New Zealand Space Policy Review consultation. It was setting up the context for regulation and public policy around space from both an aerospace perspective, but also a specifically space perspective. It ended up with then in May 2023, the National Space Policy, and in July 2023, the Aotearoa New Zealand Aerospace Strategy. Okay, again with the 2030. That's pretty much our guiding documents now about doing aerospace in New Zealand. They're very strategic. I won't go into any real detail about them. I've got separate slides if anybody wants to have a discussion about it. They're very strategic, very high level. There's very little specifics in these. Okay, so sustainability in aerospace. As I mentioned earlier, there's the need to distinguish between the benefits of aerospace-enabled data, Earth observation for environmental and resource management, and the environmental footprint of aerospace activity. Okay, so these are two things that are bound up pretty solidly in sustainability in aerospace. That leads to what we term the space sustainability paradox. In other words, the indirect environmental benefits arriving from aerospace technologies cannot compensate for the environmental degradation resulting from their activities. In other words, people will often talk about space-based technologies as providing all this data that is really useful for combating climate change, pollution, et cetera, measuring resources and management, all that kind of stuff. And that's where they'll often talk about that. And 100%, we use that, we need that, but the efforts and activities for getting this things into orbit in order to do that never actually compensate for the amount of impact getting those things into orbit does. Now, this is almost a bit of a false paradox because doing anything involves environmental impact. The thing is, what happens is that all the focus becomes on that, and we don't have a system to deal with the impact. That's the particular issue here. So the need for both benefits and impacts to be accounted for with a systems level approach, because that's particularly not what's being done. We get a lot of focus on the indirect benefits, but not the impacts. To this end, and something that's starting to be developed in some institutions, is a life cycle assessments model to be able to take this systems level approach. But there is actually a lack of coordination, a lack of collection of data between different locations, a lack of coordination between the application of life cycle assessments. It's all a bit disparate at the moment. As an aside, I particularly just wanted to mention space debris and have a short video because space debris is the big thing that often gets brought up by it's like people saying, oh, this is an obvious impact. This is from 2019. Things have increased markedly since then. The first thing, I think it was greater than getting down to a meter and above. Yes, like a meter and above. That's what's in orbit in 2019. We have added to this considerably in the last 5 years. But space debris is particularly what gets mentioned all the time. And it's a definite problem, but it's not the only issue that we've got going on here. But one thing we're particularly noticing, it's getting really crowded. If we drop it down to 10 centimeters, that's what we've got here. Now, 10 centimeters, oh, that sounds small. That's that big. And each of these pieces are going 15 kilometers a second when they're in orbit. So think about that impacting you. And the next one down goes down to about, I think, 1 centimeter or something like that. And that's still that big. And when you're going at 15 meters per second, that's going to punch a hole. Forget human-rated aircraft. If you've got a satellite in orbit, that's going to punch holes in you repeatedly. That's 1 centimeter. The next one goes down to, 10, it's like 1 millimeter. And 1 millimeter at 15 meters per second still does massive amounts of damage, particularly because at those kind of speeds, you may, 1 millimeter size piece vaporizes and just takes things with it. So when talking about sustainability, we have to mention this because this is something we have to deal with. It's a considerable problem. Now, but it's not just, there we go, 1 millimeter. And that's in 2019. Okay. Now but it's not just about the impacts and getting things into, this is, by the way, this is low Earth orbit. You can see the outer actual, it's really interesting. Now, it's not just about impacts when you're in orbit, however, because I took that photo walking home one evening in March 2020. I mean, other things in the world were happening in March 2020, but I was hoping, and a string of apologies, this was an old iPhone and it was early evening and not great night vision. But this is what is known as a string of pearls configuration. It was SpaceX launching Starlink satellites into orbit. The reason why it looked like this was it was a combination of the worst possible things. It had just been launched, so it was still getting into position and launch. So they were still all kind of in the same range before they've been spread out to take space. But also it was early evening, the sun had just set, so the sun was hitting them right at the right angle to make them all reflect and stuff. But the big problem is we're noticing increased albedo from satellites in low Earth orbit that terrestrial-based observation locations are having to increasingly compensate for. SpaceX has said, oh, we're changing the way in which we coat the outside of the satellites to reduce reflectivity. It still is a lump of metal moving across the sky, so it gets in the way of things. It doesn't even count the satellites that they've already put up there before they made the changes. And it's not just SpaceX, it's everybody else that's doing the same thing. So this is having a massive effect on the night sky, and it's going to increase. So one of the particular things about New Zealand that I think, returning back to New Zealand context, is that we've got to think about the biculturalism and opportunity and situation context for New Zealand in this in space. And one of the possibilities that's been talked about is the opportunity for an authentic partnership approach between the Crown and tangata whenua when it comes to space and sustainability. Particularly because Māori actually have a solid relationship with the night sky in a way that often gets downplayed. And this actually is not just a thing about Māori, it's also a lot of Indigenous cultures have cultural and scientific practices involving the night sky. They think about it differently. And as a policy scholar, I can tell you the usefulness of having different knowledges and conceptual frameworks that you can pull from to develop different policy approaches is actually invaluable. We have a number of approaches to do with personhood that we've done in New Zealand, simply thanks to Māori public policy ideas. And so many Indigenous groups advocate for the cultural value of space, highlight the need for a transdisciplinary approach to govern orbital resources and the development of the aerospace sector. If you're thinking about the holistic connection of land, ocean, sky, and the way in which space launch and space activities impact all of these things, having holistic knowledge systems and frameworks that can deal with these things as system-wide approaches, it kind of seems like a no-brainer. Work has been ongoing within New Zealand to develop a Māori aerospace strategy, increase public awareness of Māori astronomical knowledge and leadership in this area. There's also Okay, so one of my major critiques of those policy documents that I showed you earlier was that there was a high degree of appropriation of Māori values to justify, in fact, the arrangement within the policy approach that was being taken. But there's a growing consciousness to avoid doing that, and there was a particularly awareness of the absence of non-Māori actors, Māori actors during the space policy review. So what did we do? We came out with 2 research questions. What are the key sustainability issues, risks, and opportunities within the sector? Asking the sector to say that what theirs were. And which stakeholder groups are perceived to be responsible for enabling sustainability within the sector. So where we're looking at, what do they see as sustainability and who do they see as being responsible in this space? Okay. Our approach to this was 2022 through 2023, we did research and analysis. We did interviews, surveys, and workshops. In this year, like end of 23 going into 2024, we're working on the publications. We've just about to submit one paper and we've got another paper. We started off very, very early and got our first paper in around the literature review that actually, to our credit, and I'm extremely proud, we got in Ars Acta or Aeronautica. I'm never going to remember that one, but it's got the most amazing name, and we got into that journal, which is quite a preeminent journal, so we feel quite pleased with that. And the second publication is about to go into the Royal Society Journal, and we're working on the third now. What I'm going to focus on for remainder today is our findings from these bits, the interviews and the survey, the workshops. As I said, we're working on the paper from that at the moment. This is our, the core of our team. We're Auckland Council, planning. We had 2 wonderful RAs. She was a public policy student of mine. And we've got people from engineering, physics, environment, and Australia. So we actually were a solidly it's like transdisciplinary team for all the benefit and fun that can produce. Okay, as I said, we undertook a survey of businesses and performed one-on-one interviews to address the questions. The survey, we invited 100 New Zealand aerospace businesses to complete an online survey through Qualtrics. 5 different sections using Likert scale questions, and then open-ended questions off the back of that. The list of businesses was compiled using publicly available online listings. A representative cross-section of businesses across space and aerospace were chosen. Responses were anonymous and no identifiable information was collected. Total response was about 22% after 9 responses were removed for empty data. So okay, not great, but okay. 22% from academia and education, the rest were from industry. We then did interviews off the back of that were designed to gather key individuals' perceptions of the future of the sector, as well as risks and opportunities. As you know, for anybody doing social sciences, you get different results from workshops versus interviews. This was the point where we had interviews. We used open-ended questions, were based on the 7 questions method recommended by DPMC as a futures thinking technique. That's what was leading us towards that 3 horizons model of change that we were moving towards. Participants were provided with a particular definition of sustainable development because it was a good bouncing off point for them to think about sustainability. Participants were approached as experts from key organizations. We ended up doing about 10 interviews relevant to the aerospace sector, recruited versus via personalized invitations. 4 participants were Māori, 6 participants were non-Māori. Over 10 hours of interviews were transcribed and then collaboratively coded in vivo. The results largely from the surveys and interviews, when we start grouping them together, we broke them down into key issues, risks, and opportunities. And this is both survey and interview data that produce this. The key issues, one, space sector is extremely siloed. Okay, it's little interaction with other organizations beyond those that are involved with aerospace. People in New Zealand are often surprised that we have a space industry in New Zealand. And they often haven't heard, they may have heard of Rocket Lab, but often Rocket Lab is almost seen as an American company, which it kind of is now, but that's about the extent of what they know about it. It's very insular. It's extremely insular. As a result, and part of this is the lack of domestic talent for staffing. A lot of people involved in the space sector in New Zealand are not from New Zealand. And lacking diversity. 14% of the sector are women and 2% are Māori. Yeah.
For all of engineering space.
That's for all of engineering? Okay. Because of the siloed industry, the lack of diversity, there is a complete absence of meaningful discussions with Māori on governance and planning beyond a superficial consultation process. There's glaringly not enough to being done, and they're aware of this. People with the interviews, remember, this is stuff that's coming out of the actual interviews and surveys. So they're aware of the absence of meaningful discussions going on. They're aware of the fact that the Te Tiriti responsibilities aren't being fulfilled, that they have not enough awareness of Māori knowledge and practices around kaitiaki. So, yeah. The other one, this is an obvious one given the space debris, availability of low Earth orbit space. Ironically, space apparently does not have a lot of space, but they see it, and this was consistent across the interviews and the surveys, as a scientific problem to be solved rather than a systemic one requiring a more holistic approach. Okay, that's an important point. That, oh, if we can develop a technique to deal with this, we won't have to change the way in which we do things. Okay. Again, use of fossil fuels for energy. They were aware of the fact that so much of their way of getting into orbit requires the use of fossil fuels. Manufacturing, orbital launch provision, advanced aviation propulsion. These were stuff that they were starting to develop, but it was seen again as a scientific problem, as a technical problem they can deal with. They did see it as a driver for procuring alternate fuels, decarbonisation and electrification of future aerospace flight. The development of green fuels propped up. But these were all things that were in the future, not dealing with what they're dealing with now. Industry respondents acknowledged that environmental sustainability was not their primary challenge. That was consistent across everything. They would acknowledge it, but then would say, no, we've got more important things that we need to focus on. It was an issue for the next 20 years. It was like, oh, once we get ourselves established, then we'll look at changing things. That was the consistent refrain. Even Rocket Lab, even though the stuff we heard from Rocket Lab's language, even though they did not turn up, they didn't turn up, we didn't get them, did we? No, even though they didn't turn up, they use similar language when they're talking about things. I didn't think we did. Now, key issue was regulation. They use this as a catch-all term for all public policy, all rules, dictating the safe operation of industrial activity. They did acknowledge there was a need for clear regulation. But that comes with a caveat. It wasn't that they were seeing a need for regulation. They were seeing that there was a need, a clearness. They wanted coherency and universality about it. Emphasis on coherence and ensuring that domestic regulation aligned with international and other national regulations. In other words, they wanted it to be as easy as possible, so they didn't have to deal with multiple things, which is understandable. Reduce uncertainty for the industry, providing better planning and reduce barriers, minimize compliance monitoring costs, which are actually reasonable things. Some participants really saw regulators as a hindrance. Not all, but they did see it as a big stumbling block. That was just something they had to get past in order to do the things that they wanted to do, not as something that they saw value in. It was now shifting to risks. It was seen as a risk extended beyond environmental issues, including public safety, space debris collaboration, space data use, data privacy, and data. So data fitted, as you kind of suggest, that data fitted into this risk. They were worried that they needed the data environment to remain open access, while they also acknowledged multi-data sovereignty issues. They worried that increased privatization of services could result in siloed, inaccessible data. Certain private companies would collect data in space and then hold it for their own use and commercial benefit, rather than it being one of the things that New Zealand's actually known for is our open data environment. And it's being pushed as like a big part of our driver in this sector. Risk amplified through continued bilateral launch and funding agreements. By that, we're talking about with the US. And the US, particularly with a lot of their the agreements that they write, have control written in it around data and what we can and can't do with it. Because a lot of the launches that are occurring in New Zealand are for the US. And so that involves those kind of agreements where we can lose control of data that is collected within New Zealand. Possibility that Aotearoa New Zealand may not be able to enforce its open access data environment in this kind of context. Risks and insufficient resources available for sector growth. This is pretty much beyond seed funding. New Zealand seems to have a bunch of money that they'll throw at things, and then that's it. And just continuing on to the next step of more permanent, stable funding arrangements. I think part of it is probably, this is just me thinking this one through. I thought a big part of that is the fact that we have a brand new space industry and we don't really know what to do with it. But also New Zealand has a traditional habit in this kind of way of a lot of the business development funding that we do in this country tends to be startup focused, and we don't do a lot of good long-term funding. Again, thinking back to the unique situation for New Zealand in terms of its space system, most other countries have a public infrastructure. It may have been lessened in recent decades, but they have that. We don't. And so we don't have that public setup launch requirements that leads to inevitable and consistent funding. Everything has to go through private sector, in other words, which is far more volatile than public sector guaranteed funding. Limited political interest in leadership. Genuine leadership from government they actually wanted leadership from government. Critical to generate buy-in from the public, support from the public, as well as to provide mobilization and direction within the industry. The industry is pretty much directionless at the moment to a certain extent, because they just go where they can get funding and it's just ending up all over the place. Without such, industry may struggle with disparate goals and again, remaining siloed. Sustainability multi-partnerships will remain tick box exercises without government leadership in this space. But these were also seen as opportunities. Not that you want to have a bright side to climate change, but that's going to have as like requirements on us all to deal with this kind of situation. And they saw that as having opportunities for development within the sector. Again, space debris is both a risk, but also an opportunity. And dealing with international policies in this space was seen as maybe New Zealand might be uniquely situated to start creating some, even though we're small, we might be able to create some policy coherence in this space. They saw a massive opportunity for government here. through guidance and support for sustainability practices, through political leadership. We actually saw Judith Collins just relatively recently doing some work in, I think it was in the US, just literally in the last couple of months around pushing the New Zealand sector. Incentives for business development beyond the startup phase, developing regulatory systems that are more flexible, and that there was a possibility to build and model bicultural frameworks based around Tāwhaki down off Christchurch. Also, all of these things were seen as requirements for sustainability to actually occur, both in terms of being a sustainable industry and for the environment. Okay, so that was often, sustainable often got mentioned without being defined in a lot of these things, and it got used both in terms of sustainable as in the industry being able to sustain itself, as well as sustainability in terms of the environment. Current nascent nature of the sector combined with Aotearoa New Zealand's poor emissions track record, this was not seen as the industry's role, okay? They sell themselves as brand new, and New Zealand hasn't got a good track record of dealing with emissions, so why should this be our responsibility? Okay, that was what the industry was saying. Particularly within the industry, the opportunities was, some of them did see them sustainability constraints as drivers for innovation, networking with different organizations in Māori, and in other words, getting out of the silo space, allowing for accountability with the industry and transparency. But again, they saw this as a requirement for government to put the models on them. The development of proposed indicators for success. And again, they would move back to environmental modeling, Earth observation data as being one of the considered markers for success in this area. But also more informed equitable decision-making and climate change action. Again, it's all about focus on externalities to what they're actually doing, even though they saw these as opportunities. For the public, okay, I'm going to be a little bit uncharitable here, but they pretty much saw what the public should be doing is being cheerleaders for them. Okay, that's what they saw as the opportunity for the public. Was pretty much that they were cheerleaders for the industry, and they wanted to be liked by industry. A lot of people that were involved in the sector grew up with ideas of this massive groundswell of support through the early years of the space industry, that everybody supported the space industry, and that's what they wanted and saw as an opportunity for the public. Okay. And getting finally into the last bits, sustainability. The opportunities was integrated into the sector by cultivating it as a distinct skill. If New Zealand could develop skills, a workforce, techniques to integrate sustainability into the sector, they saw this as a really niche opportunity for the industry, as a way for it to differentiate itself, but also maybe include space traffic management, debris mitigation, for instance. Engineering to minimize emissions and the impacts from infrastructure. The major things, that sustainability is not a high priority for the sector, and they focus on the benefits. Developing that a little bit is, they tend to focus on the benefits of aerospace provided data to support sustainable development rather than the impact of the sector on the environment. Continued access to low Earth orbit and space traffic management framed as an externality, as a problem to solve or overcome with technical solutions. It wasn't seen as something that was a problem, rather than complicity or the need to deal with holistically. Same thing for emissions and fuel source. And the last point, we've got the government's contradictory role in this space that I mentioned. Anyone, questions? Yeah.
How much does the space industry contribute to New Zealand's greenhouse gases?
It's not a huge amount. It's because, but that's simply because the industry is so small. I think it's better to look at as a proportion of, of the contribution. Yeah. Yeah, overall it's small, but as a proportion to the contribution towards GDP, it's actually really high. Yeah. Yeah.
The number of people involved.
Number of people involved.
Yeah.
Yeah. Exactly. Yes. Yeah. And also think about it in this context. Rocket Lab's a good example of this. It's not just about launching it here in New Zealand. Get the stuff to New Zealand, and that's mostly done by ship, which is the worst.
Worst plane.
Yeah. Well. Okay. Yeah. But yeah, ship fuel oil is horrendous.
Sometimes the numbers, just comparing them, say, with commercial aviation, they don't really make sense because the impacts are so different. So commercial aviation emissions are typically at a lower altitude and there's more circulation, so they get washed out more quickly. Whereas rocket launch emissions emit into every layer of the atmosphere. And if they go into the stratosphere, there's very little circulation. So those black carbon and soot particles kind of accumulate and from re-entering vehicles as well. And that causes ozone depletion, and it's forecasting that we're actually going to undo all of the good that we've done to our ozone layer if the launch frequency continues to increase at the rate that it's increasing. So the impacts are different, and no one's really taken that into account.
Yeah. And a major, picking up on Bianca's point, the major technique for getting rid of space debris is to burn it up in the upper atmosphere. Yeah. That's the major solution. And yeah, the upper stratosphere doesn't actually have a lot of movement. It doesn't particularly circulate down. And so you're getting a ton of particulate matter in the upper atmosphere, an increasing amount of particulate matter in the upper atmosphere, which is got way higher greenhouse effect than either methane or CO2. So.
What's the tension between them? I mean, you talked about the government being, the regulator and the developer of the sector. What's the role of the regulator here compared to other countries?
The regulator is pretty minor, to be honest. And part of that is the fact we don't actually have developed processes in place. But pretty much the major regulatory activity in regards to space is launch payload approvals. We don't really have a specific environmental sustainability measure for whether or not something should be launched or not. It falls under the RMA, but the RMA doesn't compensate for launch. It might deal with some of the atmospheric low atmospheric implications of it in terms of just pollution levels and that kind of stuff. But anything beyond that, it just doesn't. It's just not for purpose.
Focuses on what health and safety.
Yeah. Also, national security. Yeah, that's the biggie. The majority of oversight on launch payloads goes to the head of the different defense ministries,
right?
Air Force, Army, etc. And they get sign off on whether or not something gets launched or not. But there's not a lot of oversight. I mean, one of the it's very loose.
So was a military payload for a country that we went in some alliance with.
Well, that's what I think of, so
would they be
the North Koreans come along and want to launch a.
Technically, yes. But the New Zealand government recently got surprised by the fact that Rocket Lab had launched a spy satellite for the US government recently. From here.
Used as a weapon, they will approve it.
Yeah. Yeah. We've never turned down a launch payload.
Right.
Ever.
That tells you the effectiveness of a regulatory.
Yes. Yeah. And when we were initially expressing our wishes to do this research, MB came back and asked, why are you doing this? Why are you doing that? We don't want to. This is a new business sector. Why are you doing this? We don't want to rock the boat for them.